A majority of you guys who are, familiar with technology and, done work in the field of technology must have developed the application on your laptop at one or the other instant. So, you guys must have developed your application over here, and then you guys must have accessed it over the local host and felt very good, right? And post that, after deploying the application on your local laptop, you must have had a thought that let us deploy it on the cloud now. So as usual, you guys, must have logged into the AWS console and then launched an EC2 instance there. This is your EC2 instance, and then you have connected to the EC2 instance and you have containerized your application, and the application is working fine. And now, when you are accessing it using the public IP along with the port, you say you see an error, connection refused, and you get stressed out, right? So, and the worst part is not the connection refused. The worst part is you have no idea why this connection was refused. You see that the application and the container is working fine, and still you cannot access the application. So this is not bad. This is good. Because today we are going to break things on purpose and fix it like real DevOps engineers. So, welcome back to Discover Newton. I am Ashish, and on this channel, we don't copy paste instructions, we debug systems like engineers. So, if you are new here, this is where we take real DevOps problems for beginners. The problems that beginners struggle with, for example, configuring AWS, Docker, FastAPI, and we actually solve them step by step you know, uh, without portraying it like a boring textbook theory, right? So I am just going to give you a quick idea what we are going to do today. So we are going to deploy an application, considering the fact that we have already developed an application on our local environment and it is working fine. So now we'll take a step ahead. We are going to launch an EC2 instance. We are going to deploy a Docker container. We are going to deploy a Docker container and expose it over the internet. And let's see, I will try to deploy it the way you are deploying, like the very first time, and let us see what all errors we get and how do we resolve them. So let us quickly go to the AWS console and let us sign in. So let us go to EC2 instance now, and now let us launch an instance. Launch without a walkthrough. Let us put this as fast API application, and let us put everything default. Nothing. We have a key pair. I think this is the key pair that I've already created. If you don't have a key pair, you can just easily download it from here. You can just name a key pair and you can download it. So this is done from my part, and I'll just launch the instance. So once the instance gets launched, we are going to create our fast API application. So I think successfully initiated. Let us see if it has been launched or not. So it is still in pending state. Let us wait for this to be launched, and quickly we'll connect from our location. So it is running. We have copied the public IP. We'll straight away go to our terminal and we are going to write SSH-I followed by our PEM file, which is fastapi key.pem. This is what we have selected, if you could remember. Followed by our username, which is ec2-user at the rate public IP. And yes, I want to connect, and I have connected. Perfect. Now I'll quickly sudo yum update. I think there is no need to update. Let's see. Yum update hyphen y. So it is going to update all the sudo yum bin user. Okay, I think it is. We don't have an explicit requirement. We are not going to debug this particular error now. So let us quickly run sudo yum install. So the error over here was udate. It is supposed to be update, but let us not go there. Sudo yum install docker hyphen y. So let us first install Docker because we are going to containerize our application. I generally prefer to containerize all of my application that I develop. Why? Because it is easy, super easy. I can save it, I can share it, and it is going to run the way it is supposed to run everywhere. So that's the benefit and beauty of Docker. Okay, installation is in process. Let us see. So this will take a while. Running scriptlet, container Linux. So just wait for a while. So our instances are running, and we hope our Docker installation to be done. So it is done. Perfect. Let us check Docker hyphen version. Let us see. Okay, Docker is perfectly installed. Now let us check, is Docker running? Docker daemon running. So the command is sudo systemctl start Docker. I am very much sure that it won't be running, but let us start Docker. It is started. Now let us see status. status status Docker. So it is running. Perfect. Beautiful. Now what we are going to do? We are going to check Docker ps. So this command is not running. Why? Because our user, what is our user? Our user is EC2 user. EC2 user is not a part of Docker group. So we are quickly going to add it to the Docker group, because currently if we run sudo docker ps, it is going to run with the sudo command. But we have to just add this particular user, EC2 user, to this Docker group. So how we can do it? We can use sudo usermod -a g followed by docker and then our user, which is EC2 user, right? And let us see, it is done. Let us quickly exit. Let us re-log in and let us see Docker ps. Perfect. Now we can do it. Now let us create a directory, sudo mkdir. Oh, sorry. Straight away make directory mkdir followed by app, cd app, and then we are going to create a file or fast API file. That is nano is the text editor, nano main.py, right? And here is the command that we have got. So what we are going to do, we are just going to copy paste this command. So this is a simple fast API application code which says that whenever you are going to, whenever the server is up and you're going to access it, it is going to say hello, fast API application is working fine. Quickly save it. Why? Now we are going to containerize it. So for that reason, we are going to create a requirement.txt file. Make sure you have to come out a step ahead. Here currently this main.py file is created inside app directory. Now we have to come outside app directory. If you see, app directory is created, but again we do not have to build anything inside that. Now what we do, we create nano requirements.txt. So nano requirements.txt is over here. Let us do it. Now what is the requirement? Fast API and UV Fast API UVCon, let us save it Y. Perfect. Now let us also create a Docker file, nano Docker file. So this is the Docker file, and we have to just copy the commands from here. So this is the Docker file. So Docker file is nothing but it is giving the instructions over here that you have to use the image which has got already base Python installed on it. Then inside that container, create a directory called as app, and then copy all the files that we have created over here inside that. And then since if you could remember inside requirement.txt, we have mentioned declared two dependencies, that is fast API and UVCon. So here we are going to install that, and inside the container we are going to expose the port 8000. And here cmd, once the container starts running, this is the command that is going to get executed. So uvcon is again the command, and here it says that inside this directory, inside this file, there is a module called app, and the host is 0.0.0.0. It means that you can access this particular application from anywhere on the internet, and the port on which the container is listening is 8000. Now quickly save it. Perfect. Now let us build the file. So it is docker build hyphen t fast API dash image followed by, where is the file currently placed? Docker file, it is placed here. So let us build the image now. So image is going to get built in layers, and once the image is built, we'll create a container. So I am very much sure that all of you guys must have built the image in the similar way, the way I have built now. So you have accessed the EC2 instance, and then you have installed Docker, you have started Docker, you have, added your user into that Docker group, and then you have created a application file, whatever stack you are using, you must have created the application file over there. Then dependencies, declaring of dependencies. Do you see here? All the dependencies are getting installed here. And then later on, what you are doing, you are also, so the image is created. So then you are containerized. You are creating an image and then you'll be running a container. Perfect. Now let us see if our image is built. Docker images. So perfect. I could see the image. Now let us run. What command do you use? Docker run hyphen D is in detached mode, followed by name of the container is, let's say Docker. No, 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 not Docker. Let's say fast API container. Followed by what image we are using? We are using fast API img. Okay, let us see. Wow, container got created. Now let us see Docker PS. So container is running, right? Now let us access it. So how we are accessing it on this EC2 instance? So we are accessing it how? We are going to put HTTP, since it is a HTTP request, followed by our IP and followed by port 8000, because that is the port on which container is listening, right? Port 8000, that is what we saw. Okay, we got a first error. So let us understand what is happening now. What we have done, we have got our EC2 instance. So this is our EC2 instance, and EC2 instance has got a public IP, right? Now, what we have done, we have created a container inside the EC2 instance, and here our application is running. And we have also mapped this particular application to be available. We have also mapped this particular application to be available over here on the container at port 8000. Now what we are doing, we are trying to access our particular application where on the public internet. So what we are doing, we are making a request to our public IP. So did we get any result? No result, connection timeout. So what we are doing over here, we are seeing, we are accessing HTTP request followed by 35.88.202.65 on port 8000. But if you see, this particular port 8000 is the port of container. There is a huge gap between the EC2 instance and the container. So here there is no mapping. So that's why even though we are accessing the correct location, the EC2 instance is not, or basically the host is not able to reach our container. So that is why this is the first error. So how we can fix this error? So what we are going to do, we are going to stop this container first. Docker stop. So we are going to do Docker stop. What is the container ID? 159. Stop. Perfect. Now we'll delete it also. Docker rm 159. Right? Now let us see. Do we have any container now? We don't have any container. Now let us recreate the container and let us map. So now what we are going to do, we are going to do. Let me change the color for you for a while. What we are going to do? We are going to do this mapping now. So this mapping, what is left? So we are going to do the mapping. So how we are going to do the mapping? We are going to use a flag called port, and port, what is the value that it takes? Host port by container port, right? So let us do. So let us do the command docker run hyphen d is the detached mode hyphen p. What did we say? The host port, the port of the EC2 instance. What port we want the EC2 instance to be mapped with the Docker container port? 8000 on the EC2 instance and 8000 on the container. So this is what 8000. Second 8000 is what we have declared in the Docker file as well. Now what we are going to do? We are going to put hyphen hyphen name. Name should be Docker. No, no, not Docker, Fast API container. Fast API container itself, followed by image, that is Fast API img. Right? Now let us see. Okay, container got created. Let us see it is running or exited. Perfect, it is running. Now fingers crossed, I think we should be able to. Now what we have done, we have mapped this to. So here our EC2 instance. So let me just let us put the IP. Public IP is not looking good, right? Okay. So what is the IP over here? Now our public IP is 35.88.202.65. Now here, this particular EC2 instance is listening at port 8000 and Docker is also listening at port 8000. Now we have mapped them. Now these two are mapped. So we are very much hopeful that when the request comes down here, we get the application. So what do we do now? Let us check. Let us close this and let us rerun. Let us copy the EC2 instance now, since we have done all the mapping, right? Now let us do HTTP followed by our public IP and what port we have mapped. So here, whenever we are putting the port, we are putting the port on which EC2 instance is listening, not on Docker. Nobody can directly access Docker. So again a problem. Now what could be the problem? Let us understand. So what we have done, so here we have created the EC2 instance. EC2 instance has got an IP, let's say 35.66.18.242, and we have opened its port 8000 to take request. We have not exactly opened, we have mapped port 8000 and the Docker container inside is listening on port 8000. So these two have been mapped, right? And this is your this is where your application is running, right? Now, these two are mapped, but still, whenever a user is trying to send a request, now the problem could be that like EC2 instance, is EC2 instance allowing the request to be coming down to port 8000, or is it like EC2 instance is denying all the requests that is coming on port 8000? Let us check the security group. So let us go to down. We'll go to security, and we are going to security, and then we are going to the security group, and then we are going to edit inbound rules. See, we have only got port 22. That means EC2 instance is rejecting all the requests that is coming on port 8000. So let us quickly add a rule and let us see if this fix. So it is going to be custom TCP. What port we want? We want 8000 from source anywhere IPv4, and let us save the rules. Now fingers crossed. So let us check now. See, the application is working, right? Now what exactly we did? We now asked EC2 instance in the security group, we asked EC2 instance to allow all the requests that is coming on port 8000, and that's how we happen to access the application, right? And so from a completely invisible fast API app to a fully working deployment on EC2, right? We fixed the host bounding, we also fixed the port mapping, and we also fixed the firewall issue. So the third part, what we did was a firewall issue, and most importantly, we debugged the entire errors layer by layer. So the next time when you see a connection refused, you know exactly where to look. And do not panic, do not guess, just debug methodologically, and it will be fixed, right? So if videos like this, saves your hours of frustration, just hit a like, drop in the comments that your issue has also been fixed, and subscribe to Discover Newton, because we solve real DevOps issues, not just classroom examples. So this is Ashish Bharti signing off. Until the next time, see you in the upcoming videos. Thank you for watching.